Hello children, welcome to channel Sube. Children, today I am going to discuss question number 26 from the MCQ part of 2021 Physics New Syllabus paper. A small spherical liquid drop of radius r and density rho falls with terminal velocity v in the air, in still air. The coefficient of viscosity of air is eta and the density of air can be neglected. Consider the following statements regarding the terminal velocity v of the droplet. Capital A statement, it is directly proportional to r squared. B, it is directly proportional to rho. C, it is inversely proportional to eta. Of the above statements, first one, only A is true, only A and B are true, all A, B and C are true, only B is true, only B and C are true. So children, to answer this problem or to answer this question successfully, you have to remember the equation V terminal velocity, I write small t here, equals 2 times a squared. A means r. In that equation we normally write a, first I write and later a squared. So this one is the equation normally we write divided by 9 eta. So here instead of normally we write simple a for radius, but in this problem they have given it as r, so let us replace it by r. So we get the equation like this, r squared. So using this equation, and also they have said that density of air can be neglected. So density of the external medium is denoted by d here in this equation, so therefore it is it can be neglected according to the question, so let us delete it, therefore we don't want that. So the equation, then we don't want this brackets even, so the equation is like this. Now you should remember this equation that comes under viscosity, the lesson viscosity. So here what they say is in these statements, it is directly what is it is terminal velocity v of the droplet, terminal velocity they are talking about. So in this equation also it is isolated here, so from this equation we can decide it is proportional to r squared. So that is correct, isn't it, because it is proportional to r squared. So if the variable is on this numerator, we say directly proportional. If the variable is in the denominator, here we say inversely proportional, so that you know. So the first one is correct according to that, because r squared is there, so it is directly proportional because it is on this line, that means in the numerator region. So first one is correct. Then it is directly proportional to rho is the density, that also correct because it is also in the numerator. So this v is proportional directly to rho, that is also correct. It is inversely that is also correct, proportional to eta. This one is at the denominator, so therefore under the line, so therefore it is correct. If something is like this, we say inversely proportional, so that is also correct. Then all are correct, all A, B and C are true, that means the answer is 5 for this question. So let us check 26. The answer is 5. 26. The answer is 5. Answer is 5. Okay. So children, now I am going to show you how to derive that equation, because when you write the essay part of this physics paper, you can't use that equation directly. You have to follow these steps in which steps in that path of derivation. So here assume that what they call liquid drop or whatever, falling in the medium, so this sphere is moving down, so radius is a, so normally we take it as a, but in this question they have taken as r, but when we derive that equation we use radius as symbol a, so I write it here instead of r. So density of this ball is rho, we take as rho, so let us write it here. Then the density of the medium, so there is a medium, it may be water, it may be air, usually air or water. So the medium, so density of medium is d, let us denote it by d, so that is the density of the medium. Then what happens when we release the, so here rho is greater than d, rho is greater than d, that means the density is greater of this ball, so therefore as soon as we drop it into water, what happens, it moves downwards, because the mg is greater than, so it has upthrust given by this medium water, it has upthrust, so capital U, upthrust, because it is in a medium, here it is water. If it is in water, normally you know upthrust is acting on this object. So when you mark these arrows, you have to show the point of force acting on acting point. Here this one is the point, otherwise you don't get marks. If you just write like this, you don't get marks. Sometimes they reserve marks for the diagram, so then you have to get that marks, so therefore you have to draw correctly the arrows. Then what else? So initially I have to say you, initially what is the condition? Mg is greater than upthrust, and also there is no any friction. Friction means friction acts against the motion is downwards, so friction means we call viscous force, that special friction given by the medium, viscous force. So the viscous force, so sometimes we call this medium the fluid. The medium is identified as fluid. Air and liquid and gases, air and water or whatever the liquid is named fluids, liquid or fluid or medium we can say. So the viscous force is 0 at the beginning. Viscous force is 0 at the beginning because still it hasn't achieved any velocity, considerable velocity. Therefore viscous force is roughly 0, because it is not achieved any velocity, still it is little by little from 0 increasing its velocity. So until a certain value is achieved, there is no considerable friction, that means viscous force. So how this motion occurs? Initially it accelerates and little by little the acceleration decreases, and finally the acceleration becomes 0. So like this, acceleration becomes 0. So a sort of graph you get like this. So this velocity is called terminal velocity, the maximum velocity. The maximum velocity is called terminal velocity. So to this axis we have taken v, the velocity. So you know the gradient of this velocity time graph, time this axis, velocity time graph. In this velocity time graph, you know the gradient is equal to acceleration. So what happens? Initially there is a gradient, that means there is an acceleration. So little by little it decreases, the acceleration decreases like this. If you draw a tangent like this, you can understand. So acceleration decreases, and finally acceleration becomes here 0. Acceleration becomes 0. Why that happened? The resultant force become 0, that's why. So finally acceleration is 0 at this point. After a little time, it is not a big time, so at this time acceleration is 0. Acceleration is 0. Equals 0. Acceleration goes to 0 as I showed. Initially there is an acceleration, that means it is increasing the velocity. So this is the graph, typical graph for such a motion. So since initially acceleration occurs, that is why we can say mg is greater than u, so there must be a resultant force. So resultant force is this one, mg minus u. So after this time it achieves a constant velocity like this, it doesn't increase furthermore. So at that time we say the velocity is, we identify it as terminal velocity. So we write it as v small t here like this, terminal velocity. So that is given by that equation 2 times a squared, a means radius, g rho in d, rho minus d divided by 9 eta, rho minus d divided by 9 eta. So that is the equation we are going to now derive. So at the terminal velocity, what happens at this time? The f equals 0. F means the resultant force. Resultant force. Resultant force is 0. That means the forces upwards equals the forces downwards. So we are now talking about terminal velocity movement or terminal velocity time. So at that time when the velocity is equal to terminal velocity, velocity is equal to terminal velocity, we are talking about that. At the terminal velocity we can write this thing, but before we can't write it, before that we can't write it, because there is a resultant force before that. So like this. So what is this viscous force? It is given by Stokes law. You learn it in the lesson viscosity, Stokes law. So it is equal to this viscous force. Viscous force is equal to 6 5 eta a v. That is given in that equation. So radius is a. That is the equation to find out the viscous force. So that is given by this Stokes law. Stokes law, there is a theory called Stokes law. So in that lesson you learn this directly. The object, if the object is a sphere, you can write this equation, viscous force. So then upthrust equals, you know, upthrust equals V rho g. That comes in the lesson mechanics. V rho g is the upthrust, you know. So we are going to now write the equation. The forces acting upwards are these two, viscous force and the upthrust. So we can write, therefore viscous force is 6 times 5 eta a v plus the upthrust is V rho g. So here this one is velocity, terminal velocity, therefore I write a small t there, terminal velocity, not volume. Here this one is volume, volume under water. So equals force downwards is mg. That's all. That is the only force towards downwards. So now let us simplify this after substituting whatever possible. So what is the volume? Volume of a sphere. Volume equals 4 divided by 3 5 a cube. That is the volume of a sphere. So we can substitute it in 6 5 eta a terminal velocity equals this thing, 5 a cube, then rho, not rho. For upthrust, what is the density? We use density, the density of the medium. Therefore this rho should change to d, v dg. Here we should write, when we try to find out the upthrust, we have to write the density of the medium, not the medium, or not the density of the object. We use the density of the object to find out the mass. So that is so. 5a cube, then dg. So we are writing this term. Only this part is v, volume, then d is there, we have to write, and g also. Mg is what? Volume density of the object. Density of the object is rho g, v rho g. Again v is this value, therefore we have to write it for the v, the same volume, like this, then rho g. Rho is correct here because rho is the density of the object. To find out mg, we write the density of the object. So now everything is written here minus, no, what is it, plus, this plus, plus here. So this term okay, this term okay, this term okay. So like that we have now written all the terms. So whatever we can simplify, divide by 2, then 2 times, here divide by 2 2 times, this one divide by 2 3 times, and 1 a cancel, this a cancel, then this becomes squared, this 3 cancel, it becomes squared because we divide by a, every terms we divide by a. Then 3 times 5, 5 also cancel, 5 cancel, then 3 times eta terminal velocity plus 2 times a squared dg divide by 3 equals 2 times a squared rho g divide by 3. So what we want is terminal velocity. Let us isolate it. 3 eta vt equals 2/3 a squared rho g. Then we take this term to right, so minus 2a squared dg divide by 3. So let us take common terms, 3 2 divided by 3 common, a squared common, g common. So in brackets rho minus d is there. So v terminal equals, we take this 3 to the right side, so it goes down, and eta also go to the denominator. So 2 times a squared g in brackets rho minus d, total thing divided by 3 times 3 9 eta. So this is the final equation. So this is the density of the object. This is the density of the medium. So this one is the radius. So I think it is clear. You have to follow this path, so you have to actually keep deriving this equation at least once a month. Then you can follow the path when you are given values in essay papers. You are given values for all these variables, so you have to follow this path. You can't use directly this equation only for multiple choice questions. So I think that is enough for this problem. I think you understand it. And also, children, I have something to tell you more. So we were discussing an object moving downwards. That means the density of the object is greater than the density of the medium. But the other direction, if the density of the object is smaller than the density of the medium, what happens? When we released it from the bottom of a liquid, say in a pond like this, so since the rho is smaller than the density of the medium, it moves upwards, you know. When the density is like that, it tries to float. So it moves upward. So it achieves a terminal velocity as previously, terminal the same way. Here mg to this direction, then the upthrust to this direction, upthrust always to upwards in the water, and it is moving upwards because this condition is there. So when it is moving upwards, the friction acts to the downwards like this. The friction means viscous force 6.5 eta AV term towards downwards. So here there is a difference, you have to identify that. This one downwards, this one downwards, like this. So the equation should be written at the terminal velocity. How this one upthrust, this velocity, and mg downward. So upthrust equals mg plus 6.5 eta AV. So you have to write the equation like this. Then you can receive the suitable answer or the value, the numerical value for the terminal velocity after substituting the given values for the variables. So that also can happen because in the exam they give both normally. In part 2 in the same question they give normally this sort of a problem. So you have to practice. In 2019 essay paper physics, you can see physics paper, the seventh essay question is in this type. So you try to answer that and you can get a practice, because if they ask questions in this viscosity part, they normally ask these types of questions. So be ready for that. Now children, let us try this problem 27. Consider the following statements made regarding electromagnetic capital EM waves. Capital A statement: they can be transverse or longitudinal. B, they require a medium to propagate. C, they are not deflected by electric or magnetic fields. Of the above statements, only A is true, only C is true, only A and B are true, only B and C are true, and all A, B and C are true. So the first statement, they can be transverse or longitudinal. So they are talking about electromagnetic waves. Electromagnetic waves always only transverse. They move like this, like ripples on a water surface, transverse waves. So they can be transverse or longitudinal is then wrong. They can't be, only transverse. They require, so you have to, so how I decided the lesson, you should remember the lesson. In the lesson they have named the transverse waves, the electromagnetic waves, as classified into that section. So therefore you can't derive it, you have to remember the lesson, because if the motion is this way, up and down, or perpendicular to the propagate the velocity, the speed, the direction of the speed, so that type of waves are called transverse waves. So that is what happening in these electromagnetic waves. The field is perpendicular to the direction of propagation direction. So that is wrong. Therefore, they require a medium to propagate. That also wrong. Even in grade 10, you know that electromagnetic waves such as light, heat, they don't want medium, because from the sun they come to our earth without using any medium. So that is wrong. Therefore, they require a medium to propagate. To propagate, no need a medium. See, they are not reflected by electric or deflected by electric or magnetic. And that is correct, because it has not a charge. Only charged particles are deflected by electric or magnetic fields. So therefore, of the above statements, what is true? Only C is true. So the answer is the second one for this question. So this one is an easy one. 27. Let us check. 27. The second one. You only need the properties. You only need to remember the properties. Properties we directly learn in the lesson. So there is no argument, no derivation. Just you have to remember the lesson. Even grade 11 lesson enough. That also enough. So children, now let's try this one. 28. The question number 28. When uranium 92 nucleus is bombarded with a slow neutron N, the following nuclear reaction may take place. So they have given a reaction. So let us magnify it a little bit, because we have to write things there. It's like this. So they have given the reaction. The values of A and B are respectively. A and B. A is this one. B is this one. It's a coefficient. So we have to find out those values. So they have bombarded this uranium with a with a neutron. So so what you need is you should know how we write this, the method of writing this equation. So this how to write these elements using these values. So in this place, so what is this 92? That is the number of protons. Here in this blank place, there should be the number of neutrons, but they don't normally write. The total number, the sum is here. That is the mass, the sum of proton and neutron. So this one is the so how to denote these elements like this. So here proton plus neutron, the number. So they have left this place empty, because we can find if we know the sum, we can subtract this number of proton, then we can get the number of neutrons. So number of neutrons here is 235 minus, that is the total, minus the number of proton, 92. So we get the number of neutron. So let us subtract 235 minus 92. So 5 minus 2 is 3, then 22 here, no 23 minus 9 is 13, 14. So the total number of neutrons is 143. Therefore we can write that value here. (143) neutrons are there. So here neutron means 1. There are 1 neutron and 1 mass. So here now we have to find out. We can get the we can write an equation for these neutrons, total neutrons. So like this, the total neutrons at the left side, how much neutrons? Here 143 plus they have added 1 neutron like this, so 1. So total left side is that. So here what is the number of neutrons? We have to find out the same way, using the same way. Let us subtract 44 from 102, then we get the number. So 12 minus 4 is 8, here 9 minus 4 is 5. 54 neutrons are there. 58 neutrons are there. So when we write the number of neutrons at right side, 58 we have to write now, 58. Then here what is the number? 131 minus simple a. The same way, that is the value. So therefore we have to write plus 131 minus a, then plus another b times neutrons here, then b number of neutrons are there. Say 10n, that means there are 10 neutrons. So therefore like that there are b neutrons, so we add this one here. So then we simplify, 144 equals 58 plus 131 minus a plus b. So we take these people to left side, 144, no, let us take a to, because that is minus, so a minus b equals these two, 58 plus 131 minus this one to right side, 144. So simplify this, so we get 45 here. When you simplify this, a minus b is 45. So one by one you have to substitute these answers. So they say 48 and 1. A is 48, b is 1. So 48, 1. Then we get 47. So not 45. That is wrong. Therefore, the first one is wrong. Then second one, 48 and 2. So here 48 minus 2. How much? 46. So what we need? 45. So wrong. Therefore that is wrong. So let us try this one. 48, 3. 48 minus 3, 45. Correct, 45, 6, 7, 8. That is correct. So this one is the answer. Third one is the answer. Therefore let us check it. 28, 28. Third one is the answer. Right. Third one is the answer. Correct. Children, now let us try this one. 29, the question number 29 of 2021 physics paper. A metal surface is illuminated with monochromatic blue, red and yellow light respectively. Consider the following statements. Capital A, if red light ejects photoelectrons, then blue light should also eject photoelectrons. B, if yellow light ejects photoelectrons, then red light should also eject photoelectrons. C, if blue light ejects photoelectrons, then red light should also eject photoelectrons. If you have learned that lesson, the radiation, we know that if there is a certain metal plate, so if a wave falls on it like this, if the photon of the wave has energy hf, energy is hf of the photon, so energy equals to phi, that is we call wave function, is used to eject the electron from this medium. So the electron is ejected like this, then it has a kinetic energy half times mv squared, half time mv squared. So the equation you know, HF equals 5 plus half mv squared. So this is the Einstein's equation, energy equation. So to happen all these things, there must be this energy HF, to have a kinetic energy, to have a velocity. Everything is occurred if only the wave has this amount of energy. To eject electrons, they are talking about to eject electrons. Eject electrons means at least this amount of energy it should has. Forget about kinetic energy, just ejecting electrons if it has HF amount of energy. So that is what we have to compare, HF, the energy HF we have to compare for all these colors. So now we have to go to the spectrum, electromagnetic spectrum, because there is the relationship this F and the color. So we know this F must be higher to eject an electron, because the energy should be sufficient. So therefore let us now go to the spectrum. You must remember that spectrum. So in this region, that is we call what? Light, LIG, visible light, LIGHT, visible light. So here ultraviolet, here X-ray, here gamma ray, here IR, infrared, then microwaves like that, then TV, then radio. At this side, this smallest f frequencies, when you go to left, the frequency increases. So the highest frequency is at this side, then this one, like this. So colors how? Ultraviolet here, infrared here, so red must be here, red must be here at this end. Ultraviolet means blue must be here, blue or purple. They talk about blue, therefore we say blue. So yellow is at the middle like this. We don't want other colors because they are talking about only these three. So now the frequency must be sufficiently higher. Frequency must be sufficiently higher. So if this one eject electrons, this one may or may not. We can't say definitely that these colors eject electrons. If this one red eject electrons, that definitely this one and this one can eject electrons, because their frequency is higher than this red even. If red at least eject electrons, so these two must eject electrons. That is how we do the logic, that means the argument. If red light ejects photoelectrons, then blue light should also eject photoelectrons. That is correct, because if red light ejects photoelectrons, so the energy, this one is enough. So this one has much enough than that red one, because the frequency is higher than red here. When we go to left, frequency increases, so the blue has much energy than red now. So then definitely if the energy is higher than red now, the electrons must be ejected. So this one is correct therefore. Second one, if yellow light ejects photoelectrons, then red light should also, if yellow light ejects photoelectrons, red line, red color may or may not eject photoelectrons, because we can't definitely say, but here they definitely say that, and so that is therefore wrong. Definitely we can't say, because we don't know about the properties of the metal. Sometimes if yellow color eject electrons, red also might eject electrons, but we can't say definitely, because the frequency is lower when we go to right side. So here the frequency of the red light is lower than yellow. If this one is at the boundary, so red light will not eject electrons then. Therefore we can't say surely. For sure we can't say. Definitely we can't say. So this one was correct, this one was wrong. If blue light ejects photoelectrons, then red light should also eject photoelectrons. That is worse than that. If blue light ejects photoelectrons, these colors have lower voltage, that means low energies. If the energies are lower, so we can't say definitely eject electrons. Sometimes they might eject electrons, because the boundary is here somewhere. They can, because we don't know what is the wave function. That means the minimum energy for an electron to be escape. We don't know that, and therefore we can't definitely say. But if this one doesn't, this one also can't. If blue light eject photoelectrons, then red light should also should. We can't say definitely. Therefore definitely we can't say. Therefore this one is wrong. Because if the boundary is here, these colors will not eject electrons, photoelectrons. We don't know where the boundary might be here or somewhere, but however boundary is right to this blue color, because blue color ejects photoelectrons. Somewhere here it may be, or somewhere here, but the boundary somewhere here, we don't know that. Therefore we can't definitely say, but they have definitely said in this answer, then red light should also eject photoelectrons. So like that we can't say. We can say might or may. So therefore this one is wrong. So first one only A. First one, the question number is 29. 29, first one is correct. So we have successfully solved the problem. First one. Right, let us go to now the next one. Now let us children try this one, question number 30 from 2021 Physics New Syllabus paper. Air is trapped in a well insulated container by a frictionless piston as shown in the figure. There is a container, frictionless piston is here that can be moved up and down. So air is trapped here like this. So there is a coil, heating element like this, fixed, no leakage is there, assume. So the air is heated by a coil of resistance 100 ohm. So R is 100 ohm, passing a current of 1 ampere. So I is equal to 1 ampere. For 5 minutes, T equals 5 minutes means 5 minutes, but we need in seconds. There are 60 seconds per minute, so 60 times 5 is 300 seconds. The air expands from a volume of 0.4 cubic meter to 0.5. What happens when we heat up this container inside? So the gas expands. What happens? This piston pushes upward. So therefore the volume increases. So piston after a while will be somewhere here like this. So the volume increased. V2 is 0.5, V1 is 0.4 cubic meter. So the volume change they have given. That means we can write delta V, volume change, 0.5 minus 0.4, that means 0.1 cubic meter. Delta V is the difference, V2 minus V1. So 0.4 minus 0.5 minus 0.4, then we get 0.1. That is it. So delta we know, and you should then remember there are equations. Delta W, work done, equals P delta V. That equation is a popular one, so you should remember that. Work done is equal P times delta U, delta V, delta V, volume change, delta V. So here again they have given the constant pressure 150 kilopascal. We have to convert it to Pascal, 10 times power 3 Pascal. So these are the data. So now this problem is a problem in thermodynamics. That means you have to use delta Q, the first equation, first law of thermodynamics, delta internal energy change plus work done, delta U plus delta W equals delta Q. So this is the famous equation there in that lesson, you know, first equation we call. So you have to find out first of all what is the heat given. Delta Q is the heat given. So you have to go to now the lesson current electricity, because in current electricity we learn energy equals, there are two equations, VIT, and also energy equals I squared R T. So since we know the value of R, we don't know the voltage, therefore we have to use this equation. Now for this problem, this equation, so let us use it. So here energy is heat, Q, delta Q, energy is delta Q, therefore we can write I squared, instead of this delta Q, I squared RT equals delta U plus this one instead of delta W, P delta V. So I is 1 ampere, therefore no need to write. R is 100, then 10 power 2. T is 300, then 3 times 10 power 2 equals internal energy change plus P is 115 10 power 4. This equals to 15 10 power 4. We took this 0 to this place. Then delta V is 0.1, but we can write 10 power minus 1 instead of that. So let us simplify, let us isolate delta U while simplifying at the same time. So here what is the value? 10 power 2, 10 power 2, 10 power 4, then 3 times 10 power 4. We take these people to left side, so minus, so cancel 1, 3, 15, 10 power 3. Then we can write this one as 30 10 power 3 minus 15 10 power 3. So the answer is 15 10 power 3. Internal energy change 15 times 10 power 3 joule. So if we write it in kilojoule, because they have answered their kilojoule as kilojoule, so 15 kilojoule, we can neglect 10 power 3 kilojoule, simple K, 15. So this one is the answer, second one is the answer. Let us check 30, second one, yes, second. So we successfully discussed that question, I think. So everything is clear. I have written everything, even these simple things I have written, these things. So you should be able to understand. These equations you should remember, otherwise we can't solve this problem. These equations you should remember, this one and this one and this one. There are 3 equations you should use in this question. So you can't give up this electricity lesson. Some people give up these certain lessons. They only practice whatever they like. If they don't like, they forget that, they leave it. You can't leave lessons like that, because they combine like this to design questions. When they design questions, they combine. So here electricity and thermodynamics, the 2 lessons are connected. There they have given a compound question. So you have to somehow learn all the lessons. You can't eliminate few of them or forget, give up some lessons. Certain lessons you can't give up. So therefore try to remember all the lessons and practice everything, electricity, thermodynamics and everything. So let us wind up now. I think you understood this, so I think you are happy. So if you are happy, please subscribe my channel, and that way you can make me happy. And don't subscribe twice, because some people had subscribed twice, because the number of this subscription decreases little by little, 1, 2 like that, because I think some subscribe 2 times, then it will be cancelled. Therefore don't subscribe twice. If you haven't subscribed yet, then only you have to subscribe. So thanks for those who have subscribed my channel, and thanks for those who watch my channel. So see you tomorrow. Goodbye.